All right, solving radical inequalities, okay? Really, there's nothing horribly different about solving radical inequalities. Remember, your inequality symbols are the less than symbol, looks like that, greater than symbol, greater than, let's have a greater than symbol, or we have our less than or equal to, greater than or equal to, okay? Those are our inequalities. Really, we solve them the exact same way. The only exception, we have two things we have to look out for. One, if you multiply or divide both sides by a negative, then you need to switch the inequality. And this just comes from the idea that if I have a true inequality, let's say 2 is less than 8. If I was to divide both of these by, I don't know, a -2, this now becomes -1. This now becomes a -4. Well, -1 is no longer less than -4, it's now greater than. By switching the sign of both sides, it switched the direction of that inequality. So that's one thing we have to look out for. Multiplying or dividing both sides by a negative, you have to switch that inequality symbol. Okay. The other thing we have to look out for when it comes to our radicals is if I have a radical and if my index here is even, we have an even index. Whatever's inside of here has to be positive. This has to be positive, greater than 0. We'd write it this way, greater than 0. So we have to keep that in consideration too. And I'll show you what I mean by that, is we always have to be looking at that even index and that radicand, making sure whatever's in there is positive. Okay, so for example, here example 7. Okay, so here again, still, first step, isolate the radical, right? So we want to get that radical by itself. So here, to isolate this radical right here, here's my radical. Okay, we would need to divide both sides. Right now it's 3 times that radical, so I would need to divide both sides by that 3. So then I left with the square root of x minus 1 less than or equal to 12 divided by 3 is 4. Now, again, we need to know, did we multiply or divide both sides by a negative? We divided both sides by a positive 3. So that's okay. We don't need to worry about this rule in blue unless we divide both sides by a negative. Okay. So then now, again, at this step, like we did over here, eliminate the radical using exponents. So we're going to take both sides of the second power. That side to the second, this side to the second. So I'm left with x minus 1 is less than or equal to 4 to the second is 16. Okay. Then we'd add 1 to both sides. So x has to be less than or equal to 15. Okay. Oh wait, 17, sorry, add 1. 16 plus 1 is 17. Okay. X has to be less than or equal to 17. But if we notice this, okay, x has to be less than 17. Here's 0. Here's 17. So that means we could equal 17, but we have to be less than 17. What happens is we get to numbers less than 17. We get into some negatives down here, right? But this is an even index. It's got an even index. So whenever you're doing an inequality with an even index, you need to make sure that whatever's inside of here, this bit has to be positive. X minus 1 has to be positive because I can't take the square root of a negative number. So our way of writing that is x minus 1 has to be positive. It has to be greater than or equal to 0. This is our mathematical way of saying it's positive. So then if we add a 1 to both sides, x has to be greater than or equal to 1. So here we'd said x has to be less than or equal to 17. Here we say x has to be greater than or equal to 1. So here's 1 right here in my number line. So it has to be greater than or equal to 1, which is here shading this direction. So really that tells me that x has to be in between 1 and 17. So we could write it this way. X is less than or equal to 17 and X is greater than or equal to 1. Okay. Or we can write it as what we call a combined inequality. And say, well, X has to be in between 1 and 17. So we would write it this way. Okay, this is the shortest way of writing it. But if this doesn't make sense to you, go ahead and write it this way. But again, this is only when we have this even index. If your index is even, then you need to do this side bit in orange. Your what we call our radicand here, the radicand has to be positive. Okay, so this radicand, this x plus 1, has to be greater than or equal to 0. Okay. All right, good luck.